Okay, so ladies and gentlemen, let's review all this. Axis of symmetry, vertex, parabola. The one thing you might want to remember is that if you pick a point here on your parabola, it's going to be exactly the same distance as the point over here, isn't it? Those two are also same distance apart, aren't they? Make sense? Remember that. Okay, let's move on. Let's talk about some other things here. You don't need to know really till chapter 9. You really don't. Minimum value. The y-coordinate of the vertex for y equals ax squared plus bx plus c, when a is greater than 0. So if they want to know, remember this, if the parabola opens up, the lowest point is going to be the vertex, right? Yeah. The y-coordinate of that vertex is called the minimum value. If the parabola opens down, yes, the highest point is the maximum. Okay? And the y-coordinate of the maximum is the maximum value.
It's the vertex.
Right. So let's talk about when it opens up. You have this. How do you know by looking at the equation whether it's going to open up or down? Do you remember?
If the A is negative, it opens down.
Right. If the A is positive, let's say this. If the A is positive, what's it going to do? Open up. Okay? So I'm just going to draw our parent function here. I'm going to kind of sketch it. If the A is positive, you will have a minimum. Minimum. Okay? So what if A is negative? It opens down and you have a maximum. So if A is negative, it opens down and you will have a maximum. Okay? Basic stuff. So, let's talk about the parent function first. This is the parent function. That is the parent function. Okay? Now, let's talk about how we can easily sketch the parent function if you just think about it. If I plug in 1 for x, what am I going to get for y?
1 of course.
1, 1. That's an obvious point on the parent function. If I stick negative 1 in for x, what am I going to get?
Negative 1.
1. Okay? Negative 1 times negative 1 is positive 1. So this is going to be another obvious point on the parent function. If you stick in 2, you're going to get 4, correct? Negative 2, you're going to get 4. You can quickly sketch the parent function by just kind of remembering those points. It's pretty easy. So there's the parent function. Okay, now, we're going to slap a 1/2 in front of it. So what happens to all my y values then? They cut in half, don't they? After I square, I cut that value in half. So in actual, what happens here is that instead of if x is 1 and y is 1, what's my y going to be? 0.5. Okay, it's the same thing over here. If x is negative 1, my y is going to be 0.5. If x is 2, instead of 2 squared equals 4, I got to cut that in half. I'm going to get 2. So it kind of, it's called a shrink. It's like I get squattier. I like to think of it as getting squattier. It's called a shrink. I make it a work. I say it is. It's a shrink. But if you wanted to be very, very particular, you would say y equals 1/2 x squared is a vertical shrink of y equals x squared. Now, you don't have to say all that. For me, you could just say shrink. We did pretty good. Now, look. You guys, if you have to draw this and you're not sure how, you can do it by hand or you can get points off the table. Look, This is x squared. This is negative 2x squared plus 4. So I stuck in negative 3. I got out negative 14. There's a point on my graph. Yes? Stuck in 0. Here's 4. It's a point on my graph. So you could always do that. Okay? All right, here we go. Now the fun stuff. Ready? Remember on the other side, this is asking me to label the vertex and the axis of symmetry. Right here, you can come up with the axis of symmetry using this handy-dandy little formula. It's actually a part of the quadratic formula. Remember, it's a vertical line, so you're looking for x equals. Hey, listen. If it goes through the vertex, if you find the axis of symmetry, then you already have the what coordinate of the vertex?
The X.
So that's what you got to do. You got to find the axis of symmetry. So we're going to use this equation. Oh, you know what? I'm doubting myself right now.
I am too.
Here we go. I always identify my A and my B and my C if I need to. What's my A? Negative 1. What's my B?
6.
6. Now I can work with this equation. X equals negative B over 2 times negative 1. So X equals negative 3, negative negative 3, and X equals 3. Did you get 3?
Yeah.
Okay. You could do it a lot quicker than that. Absolutely. I'm just showing. This shows me the axis of symmetry. Right here, see? Axis of symmetry, which is a vertical line. So I can draw that right now. That's the axis of symmetry. X equals 3. I know the vertex is on that. So what do I have to do to get the y coordinate of the vertex?
Plug it in.
Plug it into the equation. That's what I'm going to do. Plug it into the equation. So I take this and I plug it into y equals, be careful with those signs. If x is 3, I'm going to plug it in, and this is what you should get. Y equals 1. Yes?
I still get confused on like whether you like negative it after or before.
Follow order of operations. All right, so did you all get 1? So my vertex is 3, 1, so I can put a point on there, right here. 3, 1. You know what else is beautiful? Do you guys know what this is on the graph right here? Do you know what that is? It is. It's the y-intercept. It's the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to guess it to be about right here. Now remember, if 1, 2, 3, 4, 5, 6, 7, 8. Okay? Negative 8. Listen, you guys. In a parabola, you have to remember that the opposite point is going to be exactly opposite this. Right? So I can draw the other point over here, and then I can sketch my parabola.
Can't you just plug in 0 for y?
Why would you do that?
I don't know why you do that.
Okay, so you can sketch it. Do this next one. All right, let's do this one quicker. We need to find the vertex and the axis of symmetry, so let's start with this equation. X equals negative B over 2A. B is negative 2 over 2 times 1. What's X equal?
1.
Yes, it does. X equals 1. Okay? So draw the axis of symmetry. Brian? That's the axis of symmetry. Plug 1 into the equation. And you get y equals negative 2. So your vertex is 1, negative 2. Oops. 1, negative 2. Is this one going to open up or down? Up. And where is its y-intercept at? 1. y-intercept is at -1. Oopsie, not there. Here. And here.
As long as you have 3 points, you can make it parabola.
You should have 5.
But can you go with 3?
Yeah, you could sketch it with 3. I guess. Okay? Almost done. Ready? All right, ladies and gentlemen, here. Tell whether the function has a minimum or a maximum value. Do you know? By looking at it, how can you tell? Minimum or maximum? Negative, so it opens down, so it's got a maximum. Okay? Maximum. Okay, so how do you find that maximum value? It's the y-coordinate of the what? Vertex. So y-coordinate of the vertex. So you just do exactly what you were doing up here. Y-coordinate of the vertex. So first we have to find the x, and then we plug it in and get the y. Just like you did here. So we're still going to use this. And we're just going to plug it in. A is -2. B is 4. Remember A, B, and C. Okay? So x equals negative x equals 1. Plug it in. And y equals 5. That is my answer, because the maximum is the y-coordinate of the vertex. Okay? That is my answer. So guess what? You get to try this one on your own right now. Here, no, you have to square first. You have to follow order of operations, which is do exponents first and then multiply. So -2 times -2. You got to be careful on your calculator. Okay, so ladies and gentlemen, I am going to